In this lesson, we're going to begin talking about quadratic equations. So we use quadratic equations to help represent situations that move in one direction, stop, and then move in another direction. For example, when you drop a ball, it's moving downward. Once it hits the ground, it bounces back up. So it goes down, hits the ground, and comes up. We use quadratic equations to help represent lots of situations that move in the same direction. Today we're going to look at graphing quadratic equations. We're going to start by looking at some important characteristics of quadratic equations and sketching graphs, and then move to formally graphing them on the coordinate plane. Standard form of a quadratic equation, just like with linear and exponential equations, are y equals ax squared plus bx plus c. So for the most part, our quadratic equations are written in this form, and a, b, and c are important characteristics that help describe what this quadratic equation looks like. When you graph a quadratic equation, what you get is a U-shaped curve. That U-shaped curve has a very specific name. It's called a parabola. So on your calculator, go ahead and type in y equals x squared plus 2x minus 5. What you'll see is a graph that looks similar to the one below. This is a parabola. It's a parabola that is opening upwards. Now, put in the equation y equals negative x squared plus 3x plus 7. You get another parabola, but it looks a little bit different. It's opening downward. So with your parabolas, depending on what a, b, and c are, what those values are, your parabola can be moved up or down, left to right of your origin. They can be very narrow or they can be very wide. So that's what those numbers are, the variables a, b, and c. That's how they can change your parabola. Now let's talk about some specific characteristics of this parabola. One of the specific characteristics is this point down here. This point is called your vertex. Your other parabola that opens downward also has a vertex, but it's up at the top. If your vertex is down at the bottom, this is going to be your minimum, and if it's at the top, it's your max. So at the very beginning of the lesson, I talked about how parabolas are used to model situations that move in one direction, stop, and then move in the other direction. Your vertex is going to be that point where it changes directions. Another thing I want to point out is this line here. It's an invisible line, and both parabolas have it. And this is called your axis of symmetry. So it's almost cutting your parabola in half. So these are going to be some important characteristics that we're going to look at when sketching graphs of parabolas. So, more specifically, if A, so remember that standard form, if A is positive, then the parabola opens up. So if a is a positive number, so if you look at the equation we typed into our calculator up here at the top, a is a positive number, is a positive 1, and our parabola opens upwards. If a is a negative number, then the parabola opens down. So again, that second one we put in our calculator, if you look at A is negative 1, so that parabola is going to open downward. Now remember, A can be any number. It doesn't have to be 1. It could begin with a 4 or a 2 or a negative 7. But if it's a positive number that it begins with, it opens upward, like a smiley face. And if it's negative, it opens downwards, like a frown. Your axis of symmetry, remember that dotted line that cut it in half? The axis of symmetry is the vertical line that divides the parabola into two equal parts. And when we refer to that line has a name, and we write it x equals a number. There is a specific formula that we use to find that axis of symmetry, and that formula is x equals b divided by 2a. So we can use that formula to find that axis of symmetry. It will tell us what x equals. And again, remember, A, B, and C are coming from that standard form. The next characteristic we've talked about is your vertex. It's the turning point of the parabola. So it's going to be the point where if your parabola is moving downward, it's going to stop and then go up. Or if it's going up, it's going to stop and then move downward. And like we talked about in the examples above, the vertex is the lowest point. That's going to be called your minimum. And if your vertex is your highest point, that's going to be called your maximum. So let's take a look at some examples and how we can use those important characteristics to simply just sketch a graph. So the first one we're going to look at is the quadratic y equals x squared plus 8x plus 15. And to sketch a graph, all we need is the axis of symmetry and the vertex. So to get it, first we're going to get the axis of symmetry. Remember that formula is x equals b divided by 2a. So when we look at our example, a is 1, b is 8, and c is 15. Because remember, when it's in standard form, it's going to be in order for us. So we can substitute in b and a. B, we would replace with 8 over 2 times A, we replace with 1. So it's 8 over 2. 8 divided by 2 is 4. So our axis of symmetry is x equals 4. Then our vertex, what we can do is take the example we're looking at, y equals x squared plus 8x plus 15. And by finding that axis of symmetry, we found what x equals. So we can replace x in both parts with 4. So when we replace it with 4, we get 4 squared plus 8 times 4 plus 15. We know that 4 squared is 16 plus 32 plus 15. So then 16 plus 32 plus 15 equals 63. So our vertex is going to be the point, the ordered pair 4, 63. Let's back up just a minute. In our axis of symmetry formula, and I don't believe I put it up at the top either. So axis of symmetry is the vertical line that divides it. The formula, that should be a negative b divided by 2a. So let's come back here where we were working it out. That's a negative b, which makes that a negative 8, which makes that a negative 4. That looks much better. So x is negative 4. So your formula, make sure you don't forget that negative b. That's why we got such a big number when we were finding that vertex. So now let's calculate our vertex. Y equals x squared plus 8x plus 15. And then replacing our x's with negative 4. So negative 4 squared, put it in parentheses, plus 8 times negative 4 plus 15. So negative 4 squared in parentheses is 16. 8 times negative 4 is negative 32. So 16 minus 32 plus 15. And we can put that in our calculator. 16 minus 32 plus 15 is negative 1. So now we know that the vertex is the point negative 4, 1. Then we can make a sketch. So when we make a sketch, some things that we're looking for. We're looking for whether the parabola opens upward or downward, and then we label our vertex and our axis of symmetry. So because A over here on the left is a positive 1, we know it opens upward. So when we make our sketch, we're going to draw a parabola opening upward. Our vertex, we calculated, is the point negative 4, 1. And then our axis of symmetry that cuts it in half, we also calculated, is x equals negative 4. So that's basically what our sketch looks like. Noticing whether it opens upward or downward, and then labeling those things that we calculated. Let's take a look at another example. So number 2, y equals negative x squared plus 10x minus 23. First, we calculate that axis of symmetry. X equals negative b divided by 2a. Let's identify what a, b, and c are so we make sure we're using the right thing. For this one, a is negative 1, b is 10, and c is negative 23. So we're going to replace a and b. So we replace b with negative 10 over 2 times negative 1. Replace a with the negative 1. So that's going to be negative 10 over negative 2. We know a negative divided by a negative is a positive, and 10 divided by 2 is 5. So our axis of symmetry is x equals 5. Then we're going to calculate our vertex. So remember, for vertex, we take our quadratic, y equals negative x squared plus 10x minus 23, and we're going to replace both of these x's with what we just calculated. So we're going to replace those x's with 5. So negative 5 squared plus 10 times 5 minus 23. Now make sure when you do negative 5 squared, we replaced x with 5. So that's why just the 5 is in parentheses. So 5 squared is 25, but we have that negative, so it's negative 25 plus 50, 10 times 5, minus 23. We can put this in our calculator. Negative 25 plus 50 minus 23. That is going to equal positive 2. So we know our vertex is the point 5, 2. So we have to have our axis of symmetry in order to calculate and figure out our vertex. So now to create our sketch, because A is negative, we know it opens downward. Our vertex, this maximum point we calculated was the point 5, 2. And then our axis of symmetry that divides it in half is x equals 5. If you'll go ahead and highlight numbers 3, 4, 5, and 6, and then highlight number 7, and let's take a look at number 8. So number 8, we're doing the same thing, but if you notice, we don't have a C. We only have an A, which is negative 1, and a B, which is 4, which is okay. That's all we need. So make sure when you do this one that you're using just A and B. Highlight 8. And number 9, even more important, you can see on number 9, A is 1, B is not negative 3. Negative 3 is C. So in your standard form, that last variable C is your constant. So there's no B here. So if there's not a B, the number we use to represent something that's not there is 0. So even though you don't have visually a B to look at, B is there. B is 0. So A is always going to be your variable that's squared. B is always going to be the variable raised to the first power, and C is always going to be your constant. So make sure when you do number 9 that you use 0 for B. So go ahead and highlight number 9 and number 10. Now let's look at more formal ways that we can graph quadratic equations on a coordinate plane. So the steps you want to use when graphing it is first to identify the axis of symmetry, just like we did in the previous problems with the sketches. Then find the vertex. Then once you have those, you have a pretty good idea of what that graph looks like. But to get a more exact look, we want to make a table of values. And finally, graph those values. So let's put some of these on a coordinate plane. Number 1, we're going to start by finding our axis of symmetry. So negative B over 2A. We probably should put x equals. And then we can see in this one that A equals 1, B equals 0 because it's not there, and C also equals 0 because there's not a C either. So we're going to plug that in. That would be 0 over 2 times 1. So that's 0 over 2, which equals 0. So our axis of symmetry is x equals 0. Our vertex, so again, remember to find the vertex. We're going to substitute y equals x squared. We're going to replace x with what we just found as our axis of symmetry. So we're going to replace x with 0. And 0 squared equals 0. So our vertex is 0, 0. So we have a good idea of what our graph is going to look like. We know that that vertex point is going to be at our origin. But like I said earlier, your graph can be very narrow or very wide. So our table of values is going to help us determine how narrow and how wide it's going to be. So because my vertex is at 0, that's going to be the point on my table of values that's in the middle. And remember, we always want to have a good picture of our graph. So we want a few points on one side of our vertex and a few points on the other. So my other x values that I'm going to use are -2 and -1, and then 1, 2. To find our y values, we're going to substitute in those x values into the y equals x squared, our original equation. So we're going to replace x with -2. That's -2 squared. We're going to replace it with 1, -1 squared. We already have the 0, so then we're going to replace x with 1, 1 squared, and replace it with 2, 2 squared. -2 squared is 4. -2 times -2 is 4. -1 squared, -1 times -1 is 1. 1 squared is 1. 2 squared is 4. So now I have an even better picture and can graph these points. So I'm going to start with my origin, 0, 0. Then I'm going to graph my negative values, -2, 4. I go to the left 2 and up 4. -1, 1. 1, 1. And 2, 4. And remember, this is a parabola, so the left side and the right side should mirror each other. They should be symmetric. So that's what you're looking for, is kind of that V shape. And then once you have that, you can connect your points, making your parabola. Now let's talk about domain and range. Remember, from previous lessons, we know that domain is our x values and range is our y values. So, for our domain, going across our x-axis, we look up and down to see if we can hit our graph. So, going across the x-axis, I can see if I'm here and I go up, I do hit my graph. If I'm here on this side of the origin and go up, I also hit the graph. Even if I'm out here, looking at my graph, I can't see that it would hit, but knowing that it keeps going, eventually I do hit that graph. So I know that my domain is all real numbers. Your range is a little bit different. So your range is your y value. So looking at the y-axis, we're going to look left and right. So looking left and right, if I start up here, or let's start down at the bottom, below the origin. If I go to the right, I don't see my graph. If I go to the left, I don't see it either. When I start seeing it, as I'm moving up, I start seeing it once I get to my origin. So that's where our range is going to start. So once I reach my origin, if I stop here at 3, if I go to the right and the left, I hit my graph. If I go up to 7, if I go to the right and the left, I hit my graph. Even if I were to go up to 12, I'm still going to hit it even though I can't visually see it. So my range starts at where y is 0 and goes up. So my range is going to be y is greater than or equal to 0, because it starts at 0 and is anything greater than 0. Go ahead and highlight number 2, and let's look at number 3. So number 3, we have -x squared minus 8x minus 17. A is -1, B is -8, and C is -16. Finding your axis of symmetry, -b over 2a, that's -8. So we have two negatives here. We have a negative from our formula, and then we have a negative because b is -8. That's over 2 times -1. Now a negative times a negative makes this a positive 8. Over 2 times -1 is -2. 8 divided by -2 is -4. So our axis of symmetry is x equals -4. Our axis of symmetry is where we want our middle of our table to be, at -4. So maybe if you want to draw an arrow to help you remember, your axis of symmetry is going to be the middle of your table. So then we can fill in the rest. -6, -5, -3, -2. So these are a little bit different than the ones we've looked at in the past. In the past, we have our 0 in the middle with some positive and some negatives. For these, we want our vertex in the middle with some on the right, some on the left. That may not necessarily be positive and negative. Then to get our y values, we're going to take -x² minus 8x minus 17, and we're going to replace x with -6. Then we're going to replace it with -5, -4, and so on. And you can use your calculator for this. Just make sure as you're replacing it, especially since we're dealing with negatives, as you're replacing x, you put x in parentheses. The x that's in the formula or in the equation does not go in the parentheses. Only the negative that the number is inside the parentheses. So using a calculator, you should get -5, -2, -1, -2, -5. And if you've noticed, what is happening with your y values is, for this particular example, your y values are going up, it reaches your vertex, and it comes back down. So you should see, just like your graph is a mirror image with that symmetry, your y values do the same thing. Now that we have our table, we can go back. So this is a little bit different than we did number 1. My vertex is this middle of the table. So my vertex is the point -4, -1. So now I can graph all of these points, starting with that vertex, -4, -1, -6, -5, -5, -2, -3, -2, and -2, -5. And then we can connect those. And we know it's making a parabola, so if I plot all of my points and I get something weird with my dots all over the place, I know I've probably done something wrong. So all of your points should have that vertex with 2 on the right, 2 on the left. And then we can see that our domain, so again, the x values, if we check up and down, we can see that that is all real numbers. And then our range, our y values, I can see when I'm up here in my positive range, there's no graph. I don't start getting a graph until I get to -1. And then that's when I can start hitting my graph. So anything beginning at -1 and lower. So my range, again, is my y value, so it always starts with y. This time it's going to be less than or equal to, because it's lower. It's at the bottom of our graph. Less than or equal to -1. Go ahead and highlight number 4, 5, 6, 7, and then on the next page, 8, 9, and 10.